Okay, guys, I hope you've had a good week so far. I am going to get started on packet number 4. Okay, now you don't have this packet. I didn't print it out for you before we left, so you will have to either do it in your notebook or I've attached it or linked it on EduFlow. So feel free, if you do have a printer, you can print it out. You can print it out in pages. You don't have to print out the whole thing at once because it's a large document. Today we'll be going through page probably 74, starting on page 68 and going through 74. So if you want to print those first handful of pages, you can print the whole thing or just do it in your notebook, whatever works for your situation. Okay, but I am going to be starting, for those of you who do print it out, I'm going to be in packet 4. Okay, and I'm going to be starting on page 69. Okay, so that's where I am. Packet 4. You can see it there. That says packet 4, and we're on page 69. Okay. So far we've done graphing, we've done substitution, we've done linear elimination using addition and subtraction. Today we're going to be using linear elimination or combination using multiplication. Okay, and this is kind of the last method that we're going to use when solving these systems. Okay, so today we're moving on to solving using, like I said, linear elimination. Okay, using multiplication. And again, some people call this method linear combination. So it's not all that different than what we did the other day with linear elimination combination. It's just now we're going to be multiplication. Our goal is to, why do I have that on there? Cross off divide. We don't want that. It's to multiply. Okay, our goal is to multiply one or both of the equations by a number in order to get one variable to eliminate or drop. Or cancel. So we only have one variable left. Okay, so let's just talk about the methods we've done. I know I keep doing this, but it's important that we just kind of summarize them. Up until this point, let's see if we can get this to focus a little bit. It looks kind of hard to read. A little better, I guess. Okay, we've done graphing. And we know, because I've said it a million times, that it's a good visual. And really, if I'm being honest, it's imprecise. I don't love it. I know none of you do. And you always say and tell me, oopsie, that it's time consuming. And I completely agree, which is why we don't do it all that often. Okay. We're going to do it when you need a visual for some reason, or I make you. And I just say that because it's one of the standards and I have to teach it to you. Okay. Substitution. It can be easy to do. Okay. Disadvantage, when the variable with a coefficient of, sorry, I'm losing my train of thought. The disadvantage is when the variable with the coefficient of something other than 1 or -1. Okay, if it's something other than 1 or -1, it's not really that easy to use. Okay. When to use it? When there is a coefficient of positive or -1. Okay, so if there's a coefficient positive, -1, you can solve for the x of y, isolate it, substitute it, and solve. Okay, that's when you do it. When the coefficient is something other than 1 or -1, we don't really like to do it. And that's when we get into linear elimination. Okay, easy to do. I think, I hope most of you have found that it is pretty easy to do up until this point. Okay, and the disadvantages, I don't really think there are any. Okay, and when to use it? You can always use it. But often, when coefficient is not positive or -1. Okay, that's when we're really going to use it. Okay, so let's go on to page 70. Okay, if you need to keep writing, you can always pause the video because I know some of you are doing this in your notebook. Okay, so example 1. Solve the system, put my fancy bracket in here, using linear elimination. What do you notice about this? What do you notice? You have no variable with same or opposite side. Okay, look at this. They're lined up nicely. But are any of those going to cancel? No, they're not. So everybody pay really close attention because this is like the most important, what you're going to be using the most often. You are going to multiply at least one equation by a constant, which is the same number, to get two equations that contain the same or opposite. And I'm going to highlight that because we really want them to be opposite terms, okay? You want them to be equivalent. And I'll show you what that means, okay? We have 2x, 7x, okay? Those aren't going to cancel. We have a negative y and we have a 3y. Think about what we could multiply that first equation by to get those to be opposite. Well, it's going to be 3. So watch this. If I take, let's do a different color, 2x minus y equals 4, okay? And I multiply that whole thing by 3. Watch what happens. And remember, if you do it to one side, you've got to do it to both. You get 6x minus 3y equals 12. Look what happens. I've now got a negative 3x or 3y and a positive 3y. Those things are going to be able to be canceled. Okay, let's watch what happens. Step 2, you're going to add or subtract the equations. Again, our goal is to, we always say this, to eliminate one variable. Okay, so watch what happens. Copy down the equation you just did. Okay, we've got 6x minus 3y equals 12. Okay, now copy down your other equation. Okay, we've got 7x plus 3y equals 27. I'm going to go ahead. I'm going to add those vertically like I've been doing. 6x plus 7x, you get 13x. Oh, look at that. They cancel. And 12 plus 27 is 39. Okay. And I'm going to divide by 13. And I should get x equals 3. Okay. So step 3 is going to be to substitute. And I know this is confusing right now. I promise you, if you stick with me on this video, it is going to become clear. You're going to substitute the value from step 2 into one of the, and this is no different than what we've been doing all along, the original equations, and solve for the other variable. Okay? Let's see. I'm going to go with the first one. 2x minus y equals 4. I've got an x right here. 2 times 3 minus y equals 4. 6 minus y equals 4. I'm going to subtract 6 from both sides. Negative y equals negative 2. Divide by negative 1. Get y equals 2. Write the solution as an ordered pair. Okay, so we have 3, 2. And you can check your solution. We put it into the original equations. We've got 2x minus, oopsie, that's not right. 2x minus y equals 4. Got my x and y here. I'm going to do 2 times 3 minus 2 equals 4. Well, that side checks. We're good there. Let's do that second equation. Okay, put it in the original. 7 times 3 plus 3 times 2 equals 27. Okay, we got 21 plus 6. Well, look at that. It checks. Again, we are good to go. Okay, so that works for that one. And now, guys, that is hard, really, for the most part, as hard as it gets. Okay, let's flip the page. Okay, and we're going to do 1B. If you don't have these problems, again, just copy them in your notebook. That says 6x plus y equals negative 39, and 3x plus 2y equals negative 15. Okay, now, just think it through. They're lined up. X's, Y's, we're good. But if we add vertically, nothing is going to eliminate. Okay, so let's see what's easy. Okay, we've got a 2y and a y. Ask yourself, what could I multiply? It doesn't matter which one, but I'm going to do the first one. What could I multiply this first equation by so that they cancel? What 2y plus what equals 0? 2y plus negative 2y. How do we get that to be a negative 2? By multiplying by negative 2. So I'm going to go ahead. I'm going to multiply by negative 2. Okay, I'm going to rewrite that. 6x plus y equals negative 39. I'm going to multiply it by negative 2. Okay, so when I do that, I'm going to write down my my equation, okay? Negative 2 times 6, negative 12x. Negative 2 times y, minus 2y. Negative 2 times negative 39, positive 78. Okay, now I'm going to copy down my second equation. 3x plus 2y equals negative 15. Okay, you can see right away that if you add those down, they're going to eliminate, which is exactly what we want. So let's go ahead. Let's add those two. Negative 12 plus 3, negative 9x. Cancel or eliminate, we're good. 78 plus negative 15 is going to give me 63. I divide by negative 9. I get x equals what? Negative 7. Okay, now we're just going to substitute. Okay, we've been doing this all along. This is nothing new at this point. Okay, doesn't matter which equation. I'm just going to pick the first one. We've got 6x plus y equals negative 39. Okay, we've got 6 times negative 7 plus y equals negative 39. Negative 42 plus y equals negative 39. Would help if you could see, right? We're going to add 42 to both sides. I get y equals 3. So my solution is negative 7, comma 3. Okay, there's my. Now, if you want to check it, I'm not making you right now on this one. I didn't leave room, honestly. You could check it, plug them both in to the original equations, and see what you get. Okay. Let's turn to page 72. Okay. And if you want to test yourself out, pause the video, do one, and then check it against the video to see what we're doing. Okay. Here, page 72. Okay, we've got an equation right here. I'm going to write in my fancy bracket to show that it's a system. We are on 1C, I believe. Yes. Okay. Now, this problem, honestly, is about as hard as it gets, okay? And it's not that difficult. Let's think about it for a second, okay? Using linear elimination. Okay, they're lined up. X's, Y's, constant. We're good there. Negative 3, well, that's not going to eliminate. That's not going to eliminate. We have to do some multiplication. But you can see right away that there's really nothing I can multiply just one by to get them to cancel. So look at something for a second. Excuse me. Negative 3 and 4. If I multiply this first equation times 4, that's going to give me negative 12. Do you see how those are negative and a positive? That's going to give me a negative 12. 4 times what is going to give me a positive 12? Look at that. Watch what happens. Okay? For my first equation, I multiply, remember, by everything. I get negative 12x plus 8y equals 24. Okay? I didn't change the equation. As you can see, you could divide all those by 4 and just get back down. It's just not in simplest form, right? But those two are absolutely equivalent. Okay? Because if I've done it to one side, I do it to the other. I do it to everything. So I haven't really changed the substance of my equation. Okay, let's look at the second one. I've multiplied 3 by everything. I get, see, I can do it by everything. 3 times 4 is 12x. Okay, there's my first one. 3 times 5 is plus 15y. 3 times negative 31 is negative 93. You guys should see right away what's happening. This is canceling out. We're going to be golden on this one. Watch. Let's get a different color. Remember, you're adding vertically. Okay, so I'm going to go negative 12x plus 12x. I did my job. I made it so it would eliminate. 8 plus 15. We've got a 23y. 24 minus 93. Negative, let's see, what is that? Negative 69. Okay, now I'm just solving like I always have been. Divide by 23. You get y equals negative 3. Okay, I've got one of my two variables now. Now I'm going to substitute. Okay. Let's see. Which one do we want to pick? Let's pick the first one. Okay. It doesn't matter. You can pick either original equation. I'm going to pick the first one. Negative 3x plus 2y equals 6. I promise, no matter which one you pick, you're going to get the same answer if you do it right. Got negative 3. So I got negative 3x plus 2 times negative 3 equals 6. That's going to be minus 6. Add 6 to both sides. Divide by negative 3. We should get x equals negative 4. So my solution is negative 4, negative 3. Okay? I started to say questions, but you guys can't ask me questions right now. Let's go to 1D, okay? What do we got here? This one's a mess. Why it's a mess is because nothing's even lined up right now. I've got to get this into standard form because remember, we can't do anything until we do that. Oh, it's actually not so bad, is it? I'm sorry. We just want the standard form. We want it to line up, so we want to switch the order. So let's just switch the order. Let's make this, just switch the order. 5x minus 2y equals 55. Okay? Cross that off. This is better. Now I have 4x plus 3y equals negative 2. Those are my equations, okay? Let's look. Nothing's going to cancel, so I've got to do some multiplication. Okay, let's think about this for a second. What can I multiply these by? Oh, look at that. We have a negative and a positive. That's good. So those are opposite. That's nice. But we need these to be the same thing so they cancel, okay? So if we multiply, I hope you guys are seeing this. If you multiply this by 3, okay, times 3, and you multiply this, that's going to give me negative 6. What results in this being positive 6? Times 2, okay? And that's going to give me some opposites. Watch what happens, okay? This one I'm going to get 15x minus 6y equals, that's a big number, 165. Okay, that's the first one. Second one, 8x plus 6y equals negative 4. Well, I like where this is going. Okay, let's go ahead and add vertically. 15 plus 8 is going to give me 23x. Cancel, which is what I was shooting for, equals 161. Okay, you're going to divide by 23. And I get x equals, if you take 161, I think it's 7. Let's just see. I'm going to use my calculator here. 161 divided by 23. Yep, it was 7. Guess right. X equals 7, okay? Now we're just going to substitute. Okay, so we get, doesn't matter which equation, I'm going to use the first one. 4x plus 3y equals negative 2. So 4 times 7 plus 3y equals negative 2. 28. Subtract 28 from both sides. 3y equals negative 30. Negative 10. So my solution is 7 comma negative 10. There you have it. Okay, let's, I know I'm a lot of these, but I want to make sure you're really, really solid on this, okay? Because this is super duper important. Okay, let's flip to the next page. 2 more problems, how about? We're done. I'll try to end it at 25. 1E. Okay, go ahead and put your fancy little bracket to show that it's a system. Okay, lined up nicely. Again, problem, nothing's going to cancel out if we add vertically, okay? I could do a couple different things here. Also, do you see these are all positives? There's no negatives. So I know that I'm going to have to multiply at least one or only one by a negative, okay? 4 and 3, those are pretty easy numbers. I can multiply this by 3 and this by 4. But those are going to give me 12, both on top and bottom, and that's not what I'm shooting for. So let's do this times 3, which is going to give me a 12. This, we're going to want to be opposite. We're going to want that to be a negative 12. So I hope you can see that that should be multiplied by a negative 4. Okay? That's going to give me, and again, distribute, distribute, distribute. You're going to get 12x plus 21y equals, what's 3 times? Oh, negative 240. That was an easy one. Okay? Second one you're going to get negative 12x minus 20y. What's negative 58 times 4? Positive 232. Okay. We're going to add vertically. Make sure you put that addition sign because we're going to add. And see what we did there? Those cancel out. Okay. We're going to get 1y. 21 minus 20 is just 1y. Or we can just say y. Negative 240 plus 232. Negative 8. Well, that worked out nicely. Now, pick either one. It doesn't matter. I'm going to go up to the first one. 4x plus 7y equals negative 80. Put my negative 8 in. 4x plus 7 times negative 8 equals negative 80. Okay. Add 56 to both sides. 4x equals negative 24. X equals negative 6. And we've got a negative 6, negative 8 as our solution. Okay? I promised one last problem. And let's make it page 74, 1G. Okay? Okay, this one, pain, right? Pain because we have fractions, and none of us want to deal with those fractions. I sure don't. So what I'm going to do, you can do this every time, clear that denominator out. Okay, clear the denominator. Oh, let's see what we got here. Let's do the first one. 2/5 x plus 6y. I'm going to change this into an improper fraction. 5 times 4 plus 1 is 121 over 5. Okay, now, what can I multiply everything by to clear out those 5s? I hope you see 5s cancel. You want to multiply by 5. Okay, that's going to cancel everything out. So for 2x plus 30y equals 121. Okay, that's the first equation. Now I have to do the second one. So that was equation 1. Okay, equation 2, 3x plus 1/2 y. Okay, I'm again going to turn that into an improper. 2 times 3 is 6 plus 1 is 7. 7 halves. I hope you see 2 and 2. Let's multiply everything by 2 to get rid of that denominator, to clear it out. Or as Mr. Robert used to say last year, or at least I think he did, blast out that denominator. Okay, multiply by 2. We get 6x plus y equals 7. Okay, now we have two equations. We've got 2x plus 30y equals 121. We've got 6x plus y equals 7. Okay? Let's see what we're going to do on this one. You could do a couple of different things. Okay, you could multiply the top by negative 3 to get a negative 6. You could multiply this one by negative 30 to cancel those out. That's going to give me a kind of big number. So I'm just going to go ahead, and I see this right here. I'm going to multiply by negative 3. Okay, that's going to give me negative 6x minus 90y equals negative 363. Copy that back down. 6x plus y equals 7. Add, they cancel. I get negative 89y equals, let's see if I can do mental math, negative 356. Okay. Divide by negative 89. That's going to make my brain hurt, so I'm going to go ahead and do that one in my calculator. 356 divided by 89. Oopsie. 356 divided by 89 equals, oh, look at that, positive 4. Nice. Okay, and then I'm going to go ahead and I'm going to share some space. I'm going to sub. Okay, we'll use the original. 2/5, or the first one, 2/5 x plus 6 times 4 equals 24 and 1/5. This is kind of messy, but not impossible. 2/5 x plus 24 equals 24 and 1/5. Okay, subtract 24. Let's get a different color so we can actually see. We get 2/5 x equals, that's going to be 1/5. Okay, we're going to multiply by the reciprocal. We should get x equals 1/2. So my solution is going to be 1/2, comma 4. Again, don't freak out if you get decimals or fractions. And that's 25 on the dot, okay? So I'm going to go ahead and end that. and you can carry on with the next assignment.